Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. We saw in a previous video that we could solve first order linear differential equations of the form dy by dx plus p of x y is equal to q of x, where p of x and q of x are either constants or functions of x, using an integrating factor, such that the general solution of the differential equation is given by the formula e to the power of the integral of p of x dx multiplied by y is equal to the integral of e to the power of the integral of p of x dx multiplied by q of x dx plus a constant of integration c. For more information about integrating factors, check out this video for a full explanation, and I've included a link to it in the description. So, fully equipped with this information, let's see if we can solve this first order linear differential equation using an integrating factor. So we have 2x multiplied by dy by dx plus y is equal to 6x. And in this case, we have an initial value. So when x is equal to 4, y is equal to 20. So first, let's divide through by 2x such that we can get it into a form where we can identify the functions p of x and q of x. So when we do this, we get dy by dx plus y divided by 2x is equal to 3. And so in this example, we can see that p of x, so that's the function multiplied by y, so this function here, is equal to 1 divided by 2x. And q of x, so that's the function on the right-hand side of the equation, here, is equal to 3. Our integrating factor is therefore e to the power of the integral of p of x dx. And we've already seen that p of x is 1 over 2x. So the integrating factor in this case is e to the power of the integral of 1 over 2x dx. If we now evaluate the integral of 1 over 2x dx, we find it evaluates to a half multiplied by the natural log of the absolute value of x. And using the rules of logs and taking only the positive values of x, we're left with the natural log of x to the power of a half. So our integrating factor is e to the power of the natural log of x to the power of a half, which simplifies to give us an integrating factor of x to the power of a half. So now if we plug our integrating factor into the formula shown here, we have the integrating factor, so x to the power of a half multiplied by y is equal to the integral of the integrating factor, so x to the power of a half multiplied by q of x, which is 3, dx. So now we can use the power rule to evaluate the integral of 3 multiplied by x to the half dx. And this gives 2 multiplied by x to the power of 3 over 2 plus a constant of integration c. And so plugging this solution here into here gives us x to the power of a half multiplied by y is equal to 2 multiplied by x to the power of 3 over 2 plus a constant of integration c. And this simplifies to give us the general solution of the differential equation, which is y equals 2x plus constant c divided by the square root of x. And now to find the particular solution, we need to solve for the constant c. To find c, we can use our initial value, where y is equal to 20 when x is equal to 4. And so plugging these values of x and y into the general solution gives 20 equals 8 plus c divided by 2. c is therefore 24. And so the particular solution to this differential equation is y equals 2x plus 24 divided by the square root of x.